Hey, Phil, can you hear me? Well, we'll get started. Like I said, I am Scott Kirk. I am the Environmental Compliance Manager for Savannah River Remediation. I'm also a health physicist. At Savannah River Remediation, our mission here is to treat high-level waste that was generated during the Cold War and that's stored in underground storage tanks. We vitrify this waste into a vitrified glass waste form, and we also can disposition the treated decontaminated salts into a cementitious grout waste form such that it can be dispositioned as low-level waste on site. We're very proud of the work that we do at the Savannah River site. You know, the work that we do helps reduce one of the single largest environmental liabilities for the state of South Carolina on behalf of the Department of Energy. Last year, we had a much larger internship program. We took several of our interns to Dr. John Till's farm last year. It's close, just outside of Orangeburg, South Carolina. The enrollment this year in the internship program has been greatly reduced due to COVID-19. And while we could not travel with our interns this summer to John's farm, we decided instead to bring John's farm to each of you. And that's via WebEx. We've also expanded the summer internship program as part of this lecture series to include others across the Department of Energy complex, also the SRS complex. And we've also included students to participate from Georgia Tech, Clemson, the University of Alabama, Birmingham, and Colorado State. We have a series of 5 lectures that will be scheduled every Wednesday from noon until 1 o'clock, and it will end on August the 5th. Each of our presenters, they are very renowned in their field of expertise and have volunteered their time to share their experiences in working in health physics and in supporting the nuclear industry. At the conclusion of the presentations, we will welcome questions from our audience, and we're very delighted that you joined us today. Without further ado, I would like to introduce Dr. John Till. I've known John for years. Now I'm going to show you something. John literally wrote the book on radiological risk assessments. He is the president of Risk Assessment Corporation that was founded in 1977, a research and development organization focusing on environmental risk analysis and dose reconstruction. He is a graduate of the U.S. Naval Academy and served in the U.S. Nuclear Navy program, retiring in 1999 as a Rear Admiral in the U.S. Naval Reserves. He received his bachelor's degree in radiation biology from Colorado State University and a PhD in nuclear engineering from Georgia Institute of Technology. He was a recipient of the E.O. Lawrence Award in the field of environmental science and technology from the U.S. Department of Energy in 1995. He's a distinguished member of the NCRP and presented the Lawrence S. Taylor Lecture at the annual meeting of the NCRP in 2013. He is also a 2020 recipient of Health Physics Society's Distinguished Scientific Achievement Award. John, we have many thanks for you for your service to our great nation and for your important contributions to our industry as a distinguished scientist and a renowned health physicist. With that, John, I'm going to turn this over to you.
Scott, thank you very much. What an honor this is to be invited to talk to students and other staff at Savannah River site, and others joining in. And as Scott mentioned, we had a wonderful day over here last summer, about the same time of year, here on the farm, not only looking at the farm, touring the farm, but we had a great afternoon of discussions, technical discussions about science. It was wonderful. I'm actually coming to you from my office. If I really were out on the farm, it would be a little bit warm, obviously. But I hope this system works. I've not done this before, so let's hope we can go through this talk. And basically, that's all I'm going to do is just go through a narrative. There are no equations, so all you have to do is sit back and listen. But I'm going to set the stage a little bit with this first photograph of a submarine in the year 1972. And that is not a United States submarine. That is a Russian submarine. It's an Echo 2 class ballistic missile submarine. And the reason I show you that is back in 1972, and this puts my whole talk into context. we were in the middle of a Cold War. We were in Vietnam, and the United States in early 1972 had just mined Haiphong Harbor and some of the other harbors in North Vietnam. We were concerned about the Russians' reaction, and this is the kind of a submarine that was ordered to report to Vietnam. You may recall the book, The Hunt for Red October, and the reason this is important is because this is my submarine, the USS Guardfish, SSN 612. It was a permit-class submarine. Now, I had just left the submarine when in early 1972, Dave Menton, who was the commanding officer of the sub at the time, he was patrolling outside of Vladivostok Harbor and intercepted an Echo 2 submarine. And that Echo 2 submarine was headed to the southwest, obviously headed to Vietnam. And what happened for the next 25 days, the Guardfish trailed the Echo 2. So if you ever read or saw the movie The Hunt for Red October, the movie was based in part on that episode of the Guardfish following the Echo 2. And it turns out toward the end, after about 21 days, the Guardfish was detected. But it went for over 3 weeks without ever being detected, staying within 1,000 or 2,000 yards behind the Echo 2 the entire time and staying submerged. It's quite a story. And at the very end of the trailing, the Guardfish was detected and submerged, and there ensued for about 12 hours a very high-speed chase. And if you ever saw the movie, that was at least based in part on the USS Guardfish. So I tell you that tale. Now, I wasn't on board at the time, but this is the same kind of surveillance activities that we did when I was stationed on the Guardfish. It was a very exciting time, and to be a 26-year-old lieutenant in the Navy, there's nothing that I could recommend to anybody more exciting than a career like I had. So I was very fortunate to have my Navy career, and I owe the Navy a lot. I want to just tell you from the Navy, I made a decision early on. I always wanted to be a scientist. I even found something I wrote in high school in the 12th grade, not long before graduation. And I had to write an article, a paper, on what my career, my life was going to be like. And I put in that paper, I was waiting for admission to the Naval Academy, which I did receive. And I put in that paper, I wanted to be a scientist for the Navy. And until a couple of months ago, I discovered that, and I have no idea how all of this turned out, but it certainly couldn't have turned out any better. I went to graduate school at Colorado State and then Georgia Tech, two terrific institutions, and then had the opportunity to go to Oak Ridge National Laboratory, where you see me in this photograph. I won't go into the details of what I'm doing, but I worked with using CARPEGs and plutonium and uranium, and a couple of one plutonium isotope, plutonium-244, and uranium-232, some of the most rare of the plutonium and uranium isotopes that I believe I used up all there was in the world on my experiments. The gentleman in the top right photograph with me is a great radiobiologist named John Trabalka. He's deceased today, but he was just wonderful as a mentor. So what happened was, as I was working at Oak Ridge, I was on a terrific career as a scientist, when suddenly the family farm, which is here in South Carolina, collapsed. Two of my uncles in the photograph at the top right died suddenly. in the mid-1970s. The farm was at its peak in the 1980s. It was a big dairy farm. And by 1977, I had to make a very, very difficult decision. I'd completed my doctorate degree, but I had to decide, was I going to continue at Oak Ridge, or was I going to move back to the farm and try to save it? It was in financial trouble, and so I made this decision to come to South Carolina. Everyone thought I was totally insane, but it was one of the best things that I did in life, because as a scientist, it gave me the freedom, the independence to do what I wanted to do if I could find the work. And so I was very fortunate to move back to South Carolina, where I live today. I created in 1977 a group of other scientists. It wasn't as large as you see on the screen. This is our current research team, Risk Assessment Corporation. There are no better people in the world to work with than the individuals that you see on this screen. Great people, live all over the country. Each one brings a different skill to our team. And we've been very, very fortunate to have some projects that were truly groundbreaking projects, one of which I'm going to talk about today. Just an example of some of the work that we've done. As Scott mentioned, historical dose reconstruction is a real niche that we developed very early on. I won't have time to go through these studies. Every one would be a talk just like I'm giving you today. Everyone would be very exciting to talk about, because in what we do, we've had to push the edge of this science significantly, and that's just something I absolutely love. So what we're going to talk about today is the facility on the top left, the Hanford facility. So we're going to go through this, and I want you to just sit back. There's no need for you to write anything down. There are no equations. There are very few numbers that you're going to see. They're almost all photographs. I just want to tell you a story, and I want you to put yourself in the position that I was in as a young scientist in 1988, when I had a phone call from someone on the staff of the Washington state government asking me if I would be willing to serve on a panel being put together by the governors of Oregon and Washington to study the Hanford site. I had no idea at the time what this was all about, but I agreed to do it. So let's talk about the study, and let me give you a little bit of background on what happened. Some of you, I'm sure, are familiar with Hanford. Some of you probably have not heard of the facility. This is an older photograph of the facility. But let's go back now to 1980, a little before 1988, actually, and talk about how this study evolved. And you picture yourself being in the position I was in at the time. Hanford, of course, is where our first plutonium was made for the nuclear weapons. And it's a very secretive facility, as you know, if you've read the books and heard many stories about the site. But by the mid-1980s, there was information that got into the public hands and concern about releases of iodine-131 in particular from Hanford, and especially during the very early days of the facility operation. So there was public concern, newspaper articles, people wanted to know more. So they went to the Department of Energy, who agreed to release about 20,000 pages of historical records. And this was done in 1986 and 1987. These records were primarily unclassified information. There were some classified records that were declassified for the release. But what happened was, if you put this information out, people who have some information have some knowledge about risk assessment can put the pieces together and quickly realize that there was a tremendous amount of iodine-131 released, particularly in the 1940s from Hanford. And if you go through even some rough calculations, you could determine that the potential doses to people could be significant. And for those of you who are not familiar with iodine-131, the pathway of exposure is air, release to air, deposition on grass, consumption of the grass by cows, and children and adults drinking the milk of cows, and it concentrates in their thyroid. So once this was done, the governors of Oregon and Washington got together, and they put together a review panel to look at these records in more detail to decide, is this a potentially serious problem or not? They also put together a documents review panel, technical people, to look at the documents and decide, is there enough information available to really carry out a historical dose reconstruction? So the Hanford Environmental Dose Reconstruction Project was initiated in October of 1987. It took the governors a while to come up with members of the panel. The panel first met in May of 1988, and that was my first meeting. We were actually individuals who, for the most part, did not know one another. And this is the technical steering panel charged with directing the study. Battelle Northwest was to carry out the technical work. What you'll notice is there aren't a lot of people that you recognize, more than likely. You'll see myself there in the front row, and you may recognize Jen Ressler there, and a few other folks who might be in the health physics profession, Del Barth and Bernie Schlein. But for the most part, they were individuals that had never worked with radiation before. There were meteorologists, never worked with radiation. There was an agriculture specialist, Dave Price, but he didn't know much about radiation. We had biostatisticians. So what we did was to come together as a group. We knew what our charge was, and we were on a steep, steep learning curve. 6 years later, as the project was wrapping up, these individuals knew their stuff. They really had great knowledge about radiation in their particular fields. It was a remarkable group that stayed together during this entire period of time. So that's anything you hear today is not something that I've done personally. These individuals also influenced this study remarkably. I do remember, though, I was elected to chair the panel. It was done by a vote. People could write down a name on a piece of paper. We passed it around, and Mary Lou Blazek from Oregon, she took the tally, and somehow I came out as the chairman, which, of course, I was very proud of. But you have to remember, in 1988, I had never talked to the press. I'd never been concerned about involving people in my work. I was a scientist. I did my work in my office or on site. You know, I would publish my work, and if the public wanted to read that, that was the mode of operation. So after I was elected to chairman, my responsibility was to give the first press conference. We'd only been meeting for 2 days. The very first question was asked by a reporter from the Spokane Review named Karen Dorn-Steele, who was really a good reporter, but a really, really tough lady. So here's what the press first asked me, Karen Dorn-Steele in particular. Tough question. I wasn't ready for it. I gave an answer. I did all right. But I still had a lot to learn. And this is the beginning of what we're going to talk about today, is basically how this study changed me as a scientist. And hopefully what I tell you today, you're going to carry away with you, and you'll remember some of this. You'll remember some of this. And if you just remember some of this, and you carry this on to your careers, then I've succeeded today. So let's go. This is, at the time, this was our approach to communication. Public meetings, and we had a public meeting right after the panel started. Every time we had a public meeting, the room was packed. And you can understand, people were hearing some wild things about the doses that occurred, even to children. And what were you going to do about this, panel? What are you going to do about this? And how can we trust you? And this was the mode of operation, me sitting there at behind the table, defending our scientific approach. The bottom line was, trust us. We're going to do a good job for you, the public. And when we're ready, we'll come out and tell you what we found. How wrong I was. So we're going to go through a little bit of this. And how did the panel grow? What are some of the key decisions that we had to take in this study if at the end people were going to believe us? And you have to think, too, we knew at the beginning of this study the Department of Energy was going to be investing $25 million. That was a lot of money at the time. It still is a lot of money today. And the cost was actually more than that. But our reputations were on the line as well to see that whatever we came out with, people were going to believe. So one of the first things that happened was in the way of transparency, and this is just, I'm telling you the story now, but we had planned to have a workshop. This is very early in the study, within 2 months. Atmospheric dispersion was a key element of what we had to do. We had to understand it. If something was released, where did it go? What were the concentrations in air? So we decided to have a workshop. And of course, the workshop was going to be held at Battelle. So I got a phone call the week before I was to go out to the workshop from a lady who was the leader of an environmental group called the Hanford Education Action League. It's actually a wonderful group. They stuck with us the entire study, and they too were tough on us. Their expectations were high, and they shaped this study as much as anyone. But she said, I've got some people in my group who want to come to your workshop. I called Battelle to see if that would be all right. Could we arrange passes? Could they come to the workshop? The answer was no. We can't be giving out passes to the public. And what's going to happen if the public come into your meeting? They're going to disrupt the meeting. So somehow I took that for an answer and called the lady back. Her words were very stern. She said, I can't. She said, You've got to change the way you're working, Buster. And I remember those words so clearly. And I knew I was in trouble with this lady. So I called Battelle and I said, okay, why can't we do this? And we can have the meeting outside of the facility, but why can't we arrange for them to have passes? Took a little while. It was all set up. They agreed, okay, we'll have the passes. We'll allow so many people, I don't remember the number, who came to the meeting, and it was perfect. There was no yelling. There was no concern. The individuals who came were knowledgeable. So we decided that in order to build credibility with people, everything that we did in this study had to be available to the public. It's a tough way for scientists to work, and we had certain rules that we had to follow. We always had the right as scientists to go back to our offices and work on position papers and technical work. But we couldn't hold that for long until we invited the public to take a look at it. We invited the public to come to all of our workshops and meetings. We invited them to provide peer review to the work. Once it was in draft form, we responded to all the questions. This was a huge step. This transparency was a huge step in building credibility with the public. This is just a photograph of the typical workshop we were going through. I don't remember which one this was, but there are several members of the public who are attending the workshop. And I will say from a technical point of view, the people gave us great ideas. So don't ever get the impression that you can't bring the public in and work with them and listen to them as you're going through a study like this to build credibility. It can work. There was a gentleman by the name of Tom Bailey. He was actually a farmer who lived outside of Richland. And I had noticed that he came to every meeting that we had. And he was a very outspoken individual, a very smart fellow, who was very critical of what we were doing. He was concerned that because we were working with DOE, for DOE, being paid by Battelle, which I'll get to in a moment, that we were not going to be independent and do our own thinking. I met with Tom. I went out to his farm, actually went up in an airplane and toured irrigation pivots with him, which is one of the scarier things I've done in my life. But it turned out that in October of 1988, he called me and he said, "Look, John, you're coming out for a meeting." He said, "I really like what you guys are doing, and I believe you're going to do a good job." And he said, "I want to endorse you. Could we set up a time for the press to be there?" So I said, certainly. We set it up. This is an article from the newspaper. That's Tom, that's me, and this is just one of the paragraphs in the news article from Tom. So this was just a little bit of success that we had early on in the study. But I'll never forget it because it was the first time someone who was very critical of our work came up and said, "Look, I'm going to give you guys a chance." At the end of this press conference, which you don't see at the table, he handed me a bottle. And it was a bottle of that he had saved from the Twin Cities Creamery there in Pasco. And why it's unique, if you see the very bottom of the bottle, it says phone 131. And so he said, "John, I'm going to give you this bottle. It's the only one I have, but it's symbolic of the work you're doing on iodine 131. I have the bottle right here by me in the office, and I just can't describe to you how much something like this meant to me when I'd been torn to pieces by people yelling at me, not believing what we were going to do would be credible. But I knew even at this time we had a long way to go. I had no idea the obstacles we were still to face. Declassification was a huge issue. As you know, the facilities, even to this day, because of the sensitivity of the work, a lot of what you do at the national labs, at SRS, everywhere, remains classified, and that's important. We were dealing with historical records that were 25 and 30 years old, and the first 5 years of operation of Hanford were critical to the success of developing a source term. That's when most of the iodine 131 was released. So I had a dilemma. How were we going to work with highly classified information? You have to remember, we were still out there chasing submarines, right? The enemy was Russia in 1988. We were in the Cold War. And what we needed was called production information, plutonium production information, and I needed that information declassified if we were going to calculate a source term and succeed at our work. So this is an example of the kinds of information that we had to go through. But what I decided to do was go directly to the Secretary of Energy, Admiral James Watkins, and I first sent this letter asking him for support in declassifying records over a specific period of time, and I defined very carefully what it was that I was needing to be declassified. I also went and met with Admiral Watkins, and I said, Admiral, if you want us to succeed at this project, I have got to have your support in declassification. This was a huge breakthrough for us, absolutely unheard of before, and this information that we needed was ultimately declassified so that members of the public could double-check the figures that we were pulling out to calculate our source term. Another step toward building credibility, and I really appreciate the Department of Energy, the support that they gave us at the time. We were still confronted by the stigma of being supported by the Department of Energy. And I also knew I had to find a way out of this. We were being heavily criticized, that we were being paid by Battelle, supported by the Department of Energy, that anything we did could be controlled. I knew that was not the case, but how was I going to get out of this? At the time, I went to a friend of mine at the Centers for Disease Control and explained the dilemma that we were in, and would they have an interest if we could work a deal of supporting the project. As a result, and it also happened at about the same time in the state of Ohio, Senator John Glenn was concerned about a facility that they had in Ohio called the Fernald facility. And so we made an appointment with Senator Glenn in Washington. I went in and explained what this problem was of a conflict, the perception of conflict of interest. And I said, Senator, would there be any way you would support us if we could work out a deal with the Department of Energy, the Centers for Disease Control, so that the department could provide the money to CDC, but CDC would be independent of the department and control of the funds, and they would take over the ownership of the project. And that was done. And what happened was DOE and CDC signed a memorandum of understanding that allowed the work to continue independently. This was a really big breakthrough in terms of independence, because farther down the road, it turns out that CDC took over all of the dose reconstruction projects at the Department of Energy facilities. Had we not done this, we likely would not have had the credibility in the end that we had. So this was a huge step. I'm very grateful to Senator Glenn, to the folks at CDC, and the folks at DOE who agreed to do this because it had never been done before. But again, a huge, huge step, building block in terms of our credibility. Native Americans were very, very important to this study. And as you know, if you've been to the Northwest, you live in the Northwest, Native Americans play a huge role in all that goes on there, and particularly around the Hanford site. I just wanted to show you this picture. There was a good friend of mine that helped me tremendously in understanding Native American culture, because to be honest, at the time, I knew nothing. I didn't know that the reservations were independent nations, had their own laws. I knew nothing. And Bill Burke, the second individual from the left, tutored me over a period of a couple of years and taught me so much and gave me so much appreciation for Native American culture, and I badly needed that education. As you can see, Hanford is actually surrounded by ceded land from Native American tribes, particularly the Yakima and the Umatilla and the Nez Perce, but there were 9 tribes that we invited to come into the study. Each one received a contract to work with us. Now, why did we need to get them under contract? Well, the Native Americans they're very private. What they eat, some of their customs are private, and they don't want this to become public information. And so we signed an agreement with them, but we did need information from the tribes on diet and some of the customs so that we could calculate doses. So they worked with us over the period of the study. And in particular, the Native Americans were concerned about the river pathway. As you know, fish, in particular salmon from the Columbia River, was a major component of their diet. And they were concerned because there were tremendous amounts of radionuclides released to the river at Hanford. In the end, we calculated doses to the river pathway, but what concerned them was the uptake of radionuclides by salmon, and then they're consuming tremendous amounts of salmon all year long. And so we went through the dose calculations, and in the end, it turned out that the river pathway and the doses to the Native American tribes was really not as significant as we thought it might be. And the reason was, if you think about it, and our fish experts, of course, knew this, but salmon are anadromous fish who, once they go into fresh water, they stop eating, and so the potential radionuclides getting into the salmon was limited by the fact that they didn't eat coming up the river. And this was another huge step toward building credibility with the Native Americans. That was, to me, one of the most important educations that I received in this study was working with the Native Americans. I went out and spent several days and we became friends. And I'll never forget the friendship of Bill Burke and some of the other Native Americans that really helped me better understand Native American culture. So I'll move on. And one of the things in a study, one of the points I want to make in a study like this is you can't go 6 years and not have results. Now, many members of the public were following along what we did all the way through the study, so they were somewhat aware, but no one really knew what kind of doses we were coming up with. And we decided we would go public at a national press conference on July the 12th, 1990, which we did. But we had to come up with a way, if you gave people information, could they understand it? Now, what you're seeing on the screen is very crude, but it was our best shot at giving people an idea of what their dose might be. And so what you were to do was follow the pathway and follow the box that best leads to your location, whether or not you were an infant, whether or not you drank milk. And if you wind up at a number, then you go to the next page and you could see some idea of what your dose might have been. Now, if you look at the dose across the top, it's in old units of rad. However, you will see to the right, it's a log scale, and some of the doses that we calculated, particularly for infants who consume milk, who happen to get milk from a particular dairy downwind from the primary deposition of item 131, the doses could have been very significant. We were talking about hundreds of rad to children. This was fairly astonishing to report to the press. Now, I'll tell you that this was our preliminary results, and we went back, and 2 years later came out with updated source term, better meteorology, and other model calculations that were improved over what you see here. So the doses were not nearly as large in the end as what you see on this graphic. But the takeaway from this is you can't go through a scientific study for 6 years and never report to people if it's intended to be a public study. And so we were successful. However, not entirely. You're all laughing out there, I'm sure, because this is the press on the day after, on the 13th of July. Some of the local press, you can see some of the headlines. Some babies near Hanford got twice Chernobyl dose. U.S. admits to high radiation at Hanford. 54,000 radiation victims possible. Well, you know, as bad as that seems, we did a remarkably good job at getting the facts out and helping people to understand. We brought in experts to help us understand exactly what to say in the press conferences and what not to say in a press conference. So as bad as all the press seemed, let's face it, we had their attention from here on out. So I'm going to begin to wrap this up. What I've gone through are just some of the steps that we took in a study that were profound and important in terms of building credibility and trust with the public, and at the same time doing good science. But let me leave you with a few things to remember. And this is the first one. And I hope all of you will take this with you and never, never forget it. What are the 3 most important words in risk communication? If you say, I don't know. As a scientist, we get hung up. We think we're supposed to have all of the answers. And we know we don't have all of the answers. But you wouldn't believe how powerful those 3 words can be. And one of the things that I had to learn at the Naval Academy was if you didn't know the answer to a question, you would say, I don't know, sir. But you also had to add, I will find out, sir. Now, that's important, too, as a scientist. Someone approaches you with a question, you don't know the answer, but always get back to them with the answer. Never forget it. So I'm going to give you 5 things to think about in terms of building trust and credibility in at least my field, environmental risk assessment. Never forget data and science. That's the heart of our work. We never compromise the science. We can't, okay? So anything we do has to be based on data and science. Transparency. It's so important, especially if you're in a project where you're trying to work with people and you want to build credibility with them. Have we made progress here? I'm going to come back to that at the very end, but I think so. It's got to be effectively communicated. Trust and credibility have to be earned. When I started the Hanford Environmental Dose Reconstruction Project, I was arrogant. Scott held up, the book. Well, I published a book for the NRC, edited a book for the NRC on radiological assessment. I was really proud of that. I knew my stuff. I knew my science, and I was arrogant about that. When you go into a study like this, remember, get humble. You've got to earn that credibility. You're at a point of 0 when you're starting a project like this, and people you don't know, and you're going to work with them to earn their trust. You've got to earn it. And you have to earn it by doing more than what's expected of you. Now, I know this may shock you a little bit, and what do I mean by this? But in every piece of work I've found, in every piece of work that we've been involved in, we try to go beyond what's expected. You're always looking for a new angle, another way to make a calculation, to prove that your calculation is right. This is when you really build the credibility. So remember those 5 steps. But here it is, the bottom line of credibility and trust is just as important as the science itself. Now, you know, I'm talking to you about a guy who's in environmental dosimetry, where our client, in a lot of cases, has been the public because they're the ones who have been exposed. But building the credibility and trust in risk assessment is as important as the science itself. And I know this is true because I've seen it happen. If we carry out our best possible environmental risk assessment, and in the end the results are not believed, then we have failed in our objective to communicate. If you think about it, go back to Hanford. What if we had not taken those steps in Hanford to build the trust and credibility? What if we had not been transparent? What if we had not separated the funding so that we could be independent? What if we had not worked with the Native American tribes? We could have spent $30 million on a project that the public would not have believed, and in all likelihood would have had to be done all over again. Very important to remember this. So the bottom line, and this is, I wanted to put this up as a question, have we made progress in communicating our science in the past 30 years? From what we learned in the Hanford Environmental Dose Reconstruction Project, and I wanted to talk for a minute about this. The answer is yes. We've made tremendous progress, but it's also, we have a long way to go. You know, at the Savannah River site, at all of the Department of Energy sites, they're taking their environmental data, they're putting it in databases so that they can be widely used, consistent nomenclature, accessibility. This is so important to building credibility and trust with our stakeholders. Many more things. I mean, think about our citizens advisory boards. We've been through studies like at Rocky Flats where we worked with the Citizens Advisory Board to come up with cleanup levels at Rocky Flats. A tremendous success. So all of these successes, and we're seeing them more and more today, and the way the studies are set up, evolved in some respect from what I just talked about at Hanford. So yes, we're in a new era, but we cannot afford to forget what we've learned from these studies. We've got to build on it. So with that, I'm going to say thank you, and I wish I could see everybody in person. I wish I could shake your hand and get to know you, because you're the future of our profession. Those of you out there listening who are the interns and the students, you're the future of our profession. If I've done anything today, maybe I've inspired you, and you will cross paths at some point in the future, and you can tell me that. Okay, Scott, I'm going to turn it back over to you.
Thanks, John. He's turning it over to me for now. For those of you who don't know me, I'm Leslie Wooten. I work under Scott Kirk at Savannah River Remediation and Environmental Compliance. I was going to go ahead and lead a question and answer session with John. If everybody, if possible, can raise their hand so we're not talking over each other, trying to mute and unmute, there's a raise your hand function that I'd like to use. All right, I see Aaron. Go ahead, Aaron.
Yeah, can you hear me?
We can hear you.
Okay, yeah, I have a quick question. And this is related to the Yucca Mountain project because I know that's another large research, or that was emphasis on was another large research project with a lot of public input and conflicting viewpoints. Do you think that activity could have used some of those lessons learned that you gained from that experience with Hanford?
That's a great question. I will tell you up front that I never worked on Yucca Mountain. I was familiar somewhat with the effort put into working with the stakeholders in the area. Based on what I know, we could have done a better job at Yucca Mountain. I think we could have done a lot better job at Yucca Mountain. Did they carry out some of the ideas that we developed at Hanford? Yes, I believe they did, but I do think we could have done a better job.
Thank you. And thank you for your presentation. It was very well done.
Thank you.
Thanks, Aaron. I see Phil Breidenbach has his hand raised. Go ahead, Phil.
Yeah, I solved my technical problem here, so that's a good thing. And it was just in time so that I could listen to John's presentation. I want to thank him for a great presentation. One of the things that I'm really glad that you just pounded on was, you call it trust. From a company values perspective, we call it integrity. They're really the same thing. One leads to the other. And you made a really good point that all of the folks listening really need to really think about a little bit. But we operate at the pleasure of the American people, in particular the local communities. And if they do not trust that we can do this safely, they have the final say, and you don't get to operate. That's something we need to always keep in mind. We judge ourselves based on our intention. They don't judge us based on intention. They judge us based on our actions. And John's examples as he went through here, this presentation really hit home for me on those things. I'd like to thank Scott and Leslie and the team for pulling together this lecture series. I think I'm glad I got to sit in on this one, and I think it's a great opportunity for others. I hope you tell your friends, those that got to watch this one, tell your friends about it and get them to kind of sit in on the future ones. There's 4 more scheduled for their kind of scattered throughout the remainder of the summer, and I think it's a good thing. It really falls into another one of our company values, which is continuous improvement, and the expectation under that is that we will support individual development initiatives, and I think John did a great job teaching us something today. So thank you.
Thank you.
Thank you, Phil. Patricia, I see your hand raised.
So, John, it's great to see you again. Also having technical difficulties, so hopefully I'll figure mine out as well. But it was great to see you again. Loved your presentation. Missed going to the farm last year. Was hoping to be able to do it this year, but maybe next year. So I appreciate it.
We'll
Thank
be
you
on
so much.
next year. We'll be back next year. Okay.
I hope so. Thank you again.
Great.
All right, I see some call-in users who probably can't use the raise the hand function. If there's anybody else has a question, feel free to unmute and ask John while we've got him. All right, I saw K6643. I don't know who that is. All right, if there are no further questions, thank you so much, John, for presenting to us today, and I'll let Scott say some closing remarks. Thank you.
Hi, John. Hey, that was outstanding. I've heard this presentation numerous times. Every time it gets better. The points, though, are underscored tremendously, and as Phyllis said, it's about trust, it's about credibility, it's about integrity. You and I have known each other a long time. I really have appreciated the science that you bring behind environmental risk assessment. The work that you've done out in Texas and other places has just been phenomenal. And on behalf of my whole staff, I'm very grateful that we had the chance last year to come out to your farm. But I think this is an excellent opportunity for us to reach out to many, many more students because, like you said, the interns will be standing in our shoes one day. One of the good things about this lecture series, too, though, is that we're recording these series. And so we'll be able to share not just the presentation itself, the hard copies of your PowerPoints, but also the recordings. So this will live on in time. And thanks a million for your support, for all you've done for our country, as well as our sciences. So thank you.
Thank you, Scott. Great to be here.
Okay, with that, we'll conclude the series. But next Wednesday, 12 o'clock noon, we'll start again. Margaret Severus from the U.S. Nuclear Regulatory Commission, she'll be presenting a presentation she had given just recently to the National Academy of Sciences. And this is on the security of disused sealed sources. And so please dial in next week. Again, it's Wednesday, noon to 1 o'clock, and you should have an invitation on WebEx. So with that, we'll sign off. Take care.